Your first Arduino sketch is a single page. You define some variables at the top, you start to write some functions, and then you call them in setup and loop. After a while, maybe you've added a Wi-Fi connection and some serial logging, and so your initial sketch.ino starts to get big. Then you discover that you can just add tabs. You can break this code up into pieces, and it grows across. This relieves a lot of pressure because now instead of one huge file you need to scroll through, you can just sort of click across and view your code in pieces. Maybe you have a Wi-Fi tab, and then you have an MQTT tab, and then you have a logging tab. In C, you can't use a function or variable until it's been defined. However, in Arduino IDE, all your function definitions are brought to the top automatically. You don't need to provide a prototype. That's not true for the variables. So as your project grows and you have many tabs, you start to realize that tab number 2 might want access to a variable defined in tab number 8. So you call it up front with extern. Then tab number 4 wants a variable from tab number 6, so you extern. And you realize you have initializations and externs all over the place. And you start reading some more and you're told, hey, I can just make a globals.h. Why don't I take all of these and put them in one file, call them at the beginning, then they have access to everything. That does solve the problem. What you have now is a number of tabs where every tab has access to all functions and all variables. Wherever you're at in the code, when you're trying to solve a problem, you can simply access anything you want. The probability that any of these tabs remains focused on a single concern is not very high. If you think your Wi-Fi tab is complete and you want to copy it to another project, it doesn't work, of course, because it's calling variables that don't exist in your other project and it's calling functions that don't exist in your other project. There is never a clear time to switch to libraries. Written really well, the tabs can accomplish the same thing. When you can't find your socks, you don't need to hear, hey, if you clean your room, it might be easier. But you also know that if your room was clean, you probably could have found your socks. At least when you're programming C, a little structure goes a long way. I mean, this isn't JavaScript. So no clear time to convert to libraries. But I'll tell you what, when you Google around or ask, people will tell you that the right time for a library is when you want to share that code with someone else. I kind of disagree. It certainly is a great way to share code with someone else. But the structure that libraries impose upon you is structure that helps you create organized code that can do very complex things without getting out of control. The rest of this video is broken into 3 sections. First, I want to talk about the transition from tabs to libraries. I'm going to write a program that just attaches to Wi-Fi. The details of the code are not important. I just want to show what you're already familiar with. As your sketch grows, you can move code into tabs. But once that's working, I want to show how you can convert a tab into a library. After going for that quick win, I'm going to talk about my recommended IoT library structure. There's many ways to format your library. I've found that there's 5 key points that work really well for me when doing my IoT projects. I'm able to use the same structure across all my libraries, across all my projects. It's a good starting point, a good way to get familiar with what the syntax is and how you should make your own libraries. Lastly, I'm just going to show you where you can put this thing. You can either store it locally within your project or in the global libraries folder, which makes it available to all your other code. Number 1, the transition from tabs to libraries. Let's just start with the most basic of programs. I'm going to add serial prints to both the setup and the loop just so that we can see everything's working. Of course it is. We're awake and we're now looping. Now I'm going to add Wi-Fi. We've got to give it the credentials, the SSID and password. We'll tell Wi-Fi to begin, and then we'll just go ahead and log the status in the loop. That works great. You see the 603. It starts off disconnected. It goes idle while it's waiting to connect and then gives you 3 when it is connected. But I want to get some more feedback on this connection. I want to block up in the setup and make it not continue on until we get that connection and then tell us that we are connected. In the loop, I want to check to make sure we're connected, and if we're not, I want to reconnect. And by the way, whenever I reconnect, I don't want to go back to the loop until I confirm that we are in fact connected. This also works. But now, as you can see, our main file is starting to get a little bit crowded. You've been here before. This is when you start to think, hey, why don't I move some of this functionality out to another tab? A lot of the clutter here is from our Wi-Fi implementation, so why don't we just make a Wi-Fi tab? I'm going to call it Wi-Fi Tools. First thing I want to do is grab the Wi-Fi functionality of both the setup and the loop. I'm going to go into the tab and create new functions. Let's go with Wi-Fi begin for what was in the setup. I'll tighten it up a little bit here. And let's add Wi-Fi maintain for what we had in the loop. Now that we have these two functions, we can simply use them. The functions replace the code we had here before. I'm going to pull this reference to Wi-Fi status out of the loop. That way we don't have any reference to Wi-Fi on the front page. That means we don't need this information here either. We can put this in our tab, both the library inclusion and the credentials. This is going to work, and what you see is that we have successfully abstracted all of our Wi-Fi implementation away from the main page, so our main sketch.ino is very clean. I want to take all this code from our tab and put it into a .cpp file. Then I'm going to comment out the .ino. Our code is exactly the same, but when we move from INO to CPP, this breaks Arduino IDE out of its habit of prototyping functions for you, so you have to manually prototype the functions yourself. This is still working. What I can do now is add a .h, a header file. I'm simply going to take the prototypes I added to our main INO and move them into the header file. Then in our main INO, I'm going to include that file. So when I include Wi-Fi tools.h, I get those prototypes in my main code. Now so far this just looks like a lot more work. We've added a file to do what we could have done by hand in our main code. That's true when you only have 1 or 2 items you're importing, but what happens when you have 12? Rather than providing prototypes for all these functions, it's a lot easier to include one .h. I'm going to go ahead and delete that extra tab we created. What's nice about getting the files in this format with the .h and .cpp is that they can be moved into a source folder. Arduino IDE will automatically traverse the source folder and subdirectories looking for any CPPs. Notice that the tabs are now gone from the Arduino IDE. As long as the corresponding .h is right next to it in the same folder, it will compile into your sketch. With this setup, look at how clean our main file is now. Number 2, my recommended IoT library structure. Now we're going to build the library up again from scratch, but I'm going to go more into the detail of the different syntax that we're using along the way. First, I want to talk about this if not defined tag. Let's create a new .h just in our same root directory. We're still using Wi-Fi tools.h. What we're trying to say here is if Wi-Fi tools.h has not been defined, then define it. Otherwise, skip this entire code block. What this is trying to do is ensure that your library is loaded only once. To clarify, it does not load once across the entire program. Any given INO or CPP file can have a number of includes, but each one of those includes can also have their own includes. It's possible that you're including lib1.h and lib2.h, while lib2.h is also including lib1.h. This would result in 2 calls to the same header file, which we do not want. These tags prevent that from happening. Next, let's talk about class definition. What you saw in the previous example was that we can create variables and functions and import them directly into our code. Classes give you an extra layer of abstraction. When you create a class, by default, everything you put in it is in private, meaning it can't be seen on the outside. So to make something specifically available to the outside, you want to declare it is public. Just to show what a class does, I'm going to create 2 pointless variables here, connected and channel. And I just want to show connected and channel belong to the class. So if we instantiate the class, if we create a variable of class type Wi-Fi tools, that variable will have the properties of connected and channel. So here, Wi-Fi tools is an instance of Wi-Fi tools, meaning lowercase Wi-Fi tools is the variable name and its type is uppercase Wi-Fi tools. As shown here, Wi-Fi tools now gives you access to those 2 properties we just showed you because they're listed as public. That's what a class does for you. It allows you to define a range of properties and methods which can now be exposed under this overarching name. What I just showed is not really what you use classes for. The whole point of classes is so that you can create multiple instances of the same class. Let's consider a fictitious temp sensor class that we created. Here we assume that when we create that instance, it accepts a pin number which it attaches to get its data. We also assume that the class must have some method called readTemp, which gives us a temperature sense off that pin. Although that's why we usually use classes to create multiple instances, for IoT, when I lay out my projects, I want to see Wi-Fi tools began, MQTT tools began, OTA began. It's a matter of namespacing. Even though I don't need multiple instances of those different classes, those help me organize the code. The overhead associated with an instance is very low. So when it comes to creating maintainable code, I think it's perfectly acceptable to create an instance every time, strictly for the namespacing benefits you get. So even though we're only going to have one Wi-Fi tools, I recommend we create a class for it. I'm going to author the class now, but I'm starting by thinking about how do I want to use it. I'm going to bring in a Wi-Fi tools library, instantiate it, and then I want to call Wi-Fi tools begin and Wi-Fi tools maintain. So let's come over to our header file. I've got two functions that I want to be public, begin and maintain. But that's just the header file. We need to actually write some code. I'm going to create Wi-Fi tools.cpp. And actually, I'm just going to paste in as a starting point the code we already wrote. You've seen this before. Our function names are now begin and maintain. So I'm going to drop the Wi-Fi prefix. And these function names are not meant to be globally available. They're part of our Wi-Fi tools class. So you have to designate that this way. I have to admit that this syntax for me was very confusing. It's hard to understand. For instance, why do we need two colons? It doesn't really matter. This is just the decided syntax for how we define members of a class. If we create a Wi-Fi tools class, we then code up the different members of that class with this prefix. By the way, this CPP is not yet aware of the class definition, so we have to include Wi-Fi tools.h in this file as well. We compile and have success. The next thing I want to talk about is the constructor. The constructor is an optional function that you run when you need something to happen when you instantiate a class. So when I create my Wi-Fi tools variable, do I want it to just exist or do I want some things to happen? For the IoT projects, I think the only time you're going to really need this is when you want to inject certain values into the class, such as credentials. Another good example is back to the temperature sensor or any other sensor. If you're going to have multiple sensors that need to know what pin they're attached to or how they should behave, that's another good use case for a constructor. We start out by just naming Wi-Fi tools in our class definition. This is going to be a function that creates Wi-Fi tools, the name of our class. Kind of redundant, but again, that's just the chosen syntax. Here's a good example. Let's say I don't want to have my Wi-Fi credentials in the library. I want to put it out in my main code. If I have a constructor, I can call it when I create my variable. I can pass those values in, and those values can be used to attach to Wi-Fi. That way I don't have to put credentials in my library. To do this, we have to change the definitions in both the header file and the actual .cpp. So here I'm telling the compiler that Wi-Fi tools on instantiation is going to expect two variables. By the way, when those variables come in, I want them to be remembered by the class. So I'm going to add two private variables that are going to be used to remember those. I put an underscore at the beginning to denote that these are private variables I do not expect to be available on the outside. In the code, we have to modify the definition here as well. Now we have a function that takes values and assigns them to our private variables. Our private SSID will hold the value that was given as SSID. Our private password will hold the value that was given to us as password. Okay, we compile it and it works. I'm going to undo this example for now, which means I'm going to put the credentials back into the library. That's obviously not a best practice, but we're actually going to deal with that later in the video. For now, I'm going to insert the credentials with this alternate format, which is to instantiate those private values as members of the class. Okay, next I want to talk about the public-private designators you can put in your class definition. I think the point is use them. They're great. Namespace pollution is a real thing. Of course, if you're being diligent, it's not as much of a problem, but it's very comforting to know that you can designate certain values as private and that they only remain within your class and never leave. This allows you to create a lot of the commonly used names such as counter, timer, is connected, and use those values internally in your library without causing any sort of confusion on the outside. This next demonstration is very simple. We previously took our class values and printed them to show how the class works. Now you see that I have SSID and password are private. So when I write the code to print them and try to compile, it will fail because these are private values. And lastly, I want to talk about instantiation. It's very common to see a layout like this where you include a library and then you instantiate one instance of that class. But you may have also noticed that when you include Wi-Fi.h, you can just start using the variable without instantiating it. That's because of the pattern they selected in the library. I'm going to show you here. Across all of your INO and CPP, you can always only have one instance of any variable or function. If I know for Wi-Fi or MQTT or OTA, I'm always only ever going to need one, I can simply just define that variable in the actual library. It's another CPP file just like your main code. You may have experienced from your time using tabs that once you have one instance of a variable, you can extern that anywhere else in your code and it's fine. It's saying in all cases, look, I want you to use this variable name, but it's being created somewhere else. If we add an external instantiation to our header file, that header file can be pulled in anywhere else in the code, and it will always be referring to just the one instance that we created in our library. It means that anybody that has access to Wi-Fi tools.h is always accessing the one and only Wi-Fi tools variable that we want to exist. So in summary, these are the 5 recommendations I want to make for you when you're creating your IoT libraries. First, you always use the if not defined flags. Second, you can always use a class. Sometimes you need the class, sometimes you don't, but changing up your syntax every time causes confusion, especially when you're doing this for the first time. Creating a class does not take that much memory, so just do it. Third, whether you're using it or not, just create the constructor, call it a placeholder, put it here, define it in your CPP, just so that it's there. If you ever change your mind and want something to happen on instantiation, you can just edit these files. Use the public-private nomenclature. It reduces the number of values that are being exposed to the outside and it keeps your code tighter. Lastly, it's not always the case, especially if you know you're going to have multiple instances. If you know you're only going to have one instance, a really clean way to create it is to instantiate in your CPP for the library and then call out extern in your header file so that that instance can be spread all over the code without collision. Number 3, where to store. Okay, now that our library is done, it's time to stash it somewhere. I don't know if I mentioned before, when I'm in VS Code, I'm actually in my projects folder. That is the same folder I've designated as my actual Arduino save folder. So what it means is all my projects, like library lab, will be in a folder here. But I also have this libraries folder, which is where Arduino will keep all of the third-party libraries that I downloaded. So we've got Wi-Fi tools, CPP and H, and I want to put them somewhere so they're kind of out of the way. So as long as our .cpp files are in a directory or subdirectory of source, they will be found by the compiler, but we still have to call out our .h's. And I just want to throw out a separate point, which is that you can have header files that don't belong to code. For instance, I want to have my credentials in a separate file so that I don't have to have my credentials in my library. So I'm just going to make the folder creds and call it creds.h. My Wi-Fi credentials out of the code and put them here. I'm going to be using something called a macro definition. I don't like the terminology macro, but the point is if we define values for Wi-Fi SSID and Wi-Fi pass, these values can be automatically written into our code. So if I include that creds header, I can now pull in those macro values to give me my SSID and password. That pulls our credentials out of the library altogether. It makes the sketch a little bit messier, but you can imagine you don't want to start storing credentials in files that may go somewhere else. What's nice about this layout is we've separated the creds from the library and from our main code, and so what it means is we can git ignore. So if you're using git to store your code, you can safely ensure that your credentials are not going to be stored in the cloud or anywhere in the repo. Back to our library, I'm just going to use the convention, it's not a rule, of putting my files in a folder of the same name, and I want to put that within a source folder. That ensures that the Arduino IDE will recursively find my .cpp. The .h, the header file, does need to be explicitly called out, so I'll put the path here. It works. We've got another option. This libraries folder that's in our Arduino's project folder, this is where your libraries are stored globally. So any library you put here can be accessed by other projects. When we place our libraries in that folder, we can now move to these bracket denotations. It relieves us of having to define the path. Okay, you're all buttoned up. We can close this thing out. I hope this video was helpful. I'm Larry. Thanks for watching. I'll catch you next week.